Okay, this is a run through of the 3delight ocean baking tools to use the Houdini ocean spectrum stuff and bake it out to a custom texture format, which is dynamic. So it is not a fixed resolution of textures for the entire ocean bake. It's actually storing higher fidelity information where things are closer to camera and making more use of the space, and where things are further away from camera, it's taking them down and storing them at a lower resolution so that you get pretty high fidelity texture baking without having to, try and bake something crazy like a 16K or 16K map, or even higher. So let's jump in and have a look. There are only a couple of tools involved in actually doing it, so it's going to be fairly straightforward. What I've got here is just a standard ocean setup that I would, that anyone would kind of make. We've got a grid here. It's 5 kilometers by 5 kilometers. There's a fairly nice angle to the horizon, so we're not cheating just doing a nice isometric 45-degree view down. This is actually, pretty close to camera, and then reasonably, several kilometers away from camera. So at the moment is just a really simple, gentle ocean doing its thing, and there's nothing too crazy happening there. It's just using basic spectrum. We've got some noise in there just to sort of remove some of the repeating nature of it, but obviously, you look at this kind of stuff, you can kind of definitely see repeating stuff. What I tend to do is scatter points and use the wave instancing mechanism, and that's just controlled from here like normal. So, this is a 3delight tutorial, but we might as well touch on some motion stuff too. So, the radius and the radius variations, rotation variations, and how much it rolls off between where they overlap, blah, blah. This is just, pretty standard way of breaking up generic looking oceans so that they actually have flat spots where, a real ocean would definitely have it, depending on what you're going for. So back through the camera. So that's all good and well. We've got some points there, but you never do spectrums on their own. They're always layered together with other spectrums. So I've got another spectrum here, and it just has a different amplitude and different resolution. So if I plug that in, you can see that it's definitely different. We could take this up to much higher. Obviously it's not going to play back at this resolution, but you can see there's much finer detail in there. The idea with that is that it's going to be a layer over what is sort of already happening there with the base ocean. So we plug them back in. Obviously the order doesn't matter with this stuff, it just merges the spectrums. So what you can see is that when you are using multiple spectrums, if you are using some masking, the built-in kind of noise masks, they will not get respected by subsequent spectrums. That's why you have this option down here, blend with spectrum. So you can enable that, and you can point it to this one. And if you have multiple spectrums, you can point it to multiple spectrums. It basically just stacks the noise that's coming out of those masks, and that means that the mask that you set up in maybe the larger scale stuff carries through to the smaller stuff. But you don't have to use it. You might want subtle noises to go over the top of flatter areas, but in this instance, let's say that we are. So something else that you would tend to do quite often definitely is do stuff like you would actually have VDBs to use as custom masks. So I guess I'm kind of got this one here. Let me make it bigger so we can see it. So it's all right. So that's quite big. It's just a fog volume. If I plug this into the mask field here, it's actually set to remove everything around it. So where it's 1 and where it's 0. This is a must with a certain setup. So what I often tend to do is make a volume of maybe my entire area, my entire grid and whatever else, and maybe I would even make this, and depending on the height of your waves, you might actually make the Y component of that bounds big enough to encompass it. Otherwise, if it clears the bounds of your VDB, then the masking won't get applied. And just put it in a angle. I tend to do it along one axis and then fade it down, and what that gives you is the fog volume's density is changing, so the amount of masking, imagine if it was like a shoreline. So when things get closer to the shore, you can mask them down and basically flatten out the waves, which is pretty neat, pretty handy. And I'm just plugging it into this example so that you can see that all the standard Houdini tools and workflows work. There's not really any caveats. So let's I'll plug this mask in instead of that one, and we don't need to see that. So you can see here now we have this area falling down. So if we were to remove them, see, that's what we have. Cool. So we've got this masked away, and I'm doing that sort of as it goes away from camera to the horizon. Not because you have to, just because let's just do it just to show that it actually works. Cool. And I'm always paranoid, so let's save. As far as export to 3delight concerned, we don't have to worry about anything to do with the Ocean Evaluate toolset. It's really just whatever was going to be coming out of the multiple spectrums. So you will have phase, frequency, amplitude. There'll be multiple ones of those, multiple masks. It's just requiring that we split them apart. You could write these all to disk or do them live. It really doesn't matter. It's more how heavy this kind of calculation takes in Houdini, which, to be honest, unless you stack a ridiculous amount of spectrums and try and visualize them, they're usually pretty quick anyway. So splitting by, let's just see here, mask and point mask, which are internal Houdini things, and they both need to be there, even though you don't generally see a point mask. It needs to be in there. So just to cover all bases. Here we go. We've got our mask fields in here, and we've got our spectrum fields here. All done, all cool bananas. Let's go to the ROP. The ROP itself is really straightforward. This is a camera-centric baking setup. So the camera distance comes into where the fidelity in the custom texture format is stored. So that's as much as I can say about it. I can't say any more than that. But suffice to say, it is not a uniform texture format. And we have the option to set sort of minimum distance. Anything closer than one unit is going to be said, like, that's it, that's the cutoff. Don't try and store any detail closer than that. That's higher. We don't need it. We don't care. We can focus by default on the camera frustum. That's there mainly so that, if you're really close to camera and you really need that fidelity, it's really going to concentrate what's in the viewable frustum and start to discard things as it gets outside of that. And you can pad that with the overscan. You can turn this off and the fidelity will be a little bit more generic and maybe a little bit forgiving in terms of if you moved the camera, it wouldn't break the render and wouldn't break the fidelity, but I would probably caution against it. The whole idea of this is that you are able to do something that's, within 10 or 20 or 30 centimeters of the lens up to several kilometers away, and it's not going to, crucify your network to actually be able to create the textures or to be able to render them as well. So the thing that I guess you could say is a bit maybe weird on the surface is why not use the VDBs, store the spectrum data and mask data as VDBs and just punch those into the 3delight shader. And the reason for that is that it's about removing the amount of moving parts and factoring in being able to use the 3delight cloud, which is a core component of the engine. So when you start having to worry about licensing and accessing Houdini and Houdini Engine or libraries of things to try and create on-the-fly calculations, it starts to get messy, it starts to get a bit unwieldy. So while on the surface baking to a proprietary texture format might seem a bit weird, it means that there are no moving parts. It's literally just a grid and a texture and render. So, that's where it is. But the benefit is that 3delight's displacement and subdivision technology requires no pre-tessellation, so there will always be sub-pixel. There's no limits, there's no settings for you to worry about. It's very low memory overhead generally. And like I said, this custom texture format actually stores variable resolutions dependent on frustum and distance from camera. So anyway, that's enough of that. The ocean plane size parameter in here just has to be linked to the grid that we've got going in. This just means that it's able to cover and store that area and basically use it for its projections. So I've just got a relative reference there to the grid size that we're using, and that's it. Same with the ocean plane. If it's not sitting at the origin and you've moved it somewhere else, then you'll just position those values in there. Output texture is 3delight's custom format, TDL. Resolution, to be honest, most of the time 2048 is probably fine. 4K is getting up there and it's worth testing. You can go higher, it slows down a little bit. The file sizes obviously get a bit bigger, but you don't need as much as you think you do. Ocean spectrum and mask. The mask parameter should be the picker, but it's not, so you unfortunately get that fixed. You'll have to just paste your from SOPs straight into here, but it's just pointing to those guys, the mask and the spectra that we split apart. So we've got mask, spectra, resolution, default output linked to here. We also are able to bake the cusp, which is handy for distant shots for getting cheeky white caps without having to do any sort of particles orientated stuff. You can usually plug that into emission, which is what we're going to do in this shader as well. And the results are usually, they're pretty good. Okay, so this is all done, ready to come out here and bake, and let's just bake it. So it will take, maybe 3, 4, 5 seconds to bake it, depending on the size. Okay, cool, so that's baked it out. There it is there, we're parked on frame 130. Let me just delete that old one, just make sure everything's clear. So there's our ocean spectrum, and we wanted to render it now. So as far as the ROP's concerned, everything's pretty standard, pretty normal, reasonably low settings, all good. We're just gonna render this ocean bake object. So this ocean bake object really just consists of this guy here, and it's honestly just a object merge pointing to this one, which is the low poly version, 10 by 10. Depending on the size of it, you could maybe do the divisions a bit higher. Some renderers really are not happy with the divisions of this being too high because it will subdivide and tessellate all of the primitives, and it gets very, very slow. 3delight doesn't care. So you could have this up at 100 by 100 if you want. You could probably even have it at 3 by 3 and it would be fine as well. But I think that 10 by 10 is usually pretty safe, and we just kind of, I don't think there's anything to worry about or touch there. All done. And we just want to have a look at the shading side of things now. Shading side of things is in the material builder, and standard sort of thing, terminal, principled shader into the surface component, and displacement is not using regular displacement or a layer displacement. It's using the ocean displacement special node for it, and that ocean displacement node just needs to point to this TDL, this custom image that we just wrote. So that's all done, that's there. And there is also a cusp node, which is saying same thing, point me to the same file, because the cusp data is stored in there as well. And that's essentially the shading network. I've got a little remap here, just bringing the bottom and crunching the top, so the white caps are a little bit less defined. They're not as far, they're not as large as they were straight out of the calculation. Principled shader is just set to have a little bit of roughness, pretty high spec. Refraction is completely 100% weight, normal everything else. We're also using the volumetric scattering, so we don't have to make a volume box underneath with some sort of displacement and resolution, which would be cool to do. You can do it, and I think you can get much more advanced looks, but that's probably not something you would worry about for low sort of, this type of ocean, not something where you're going to see something swimming around underneath and jumping out. So to use this, it's a little bit counterintuitive because the defaults are volumetric transparency is at 1. Basically, when this is at 1, it's just a regular, completely regular refractive surface. When you drag this slider towards 0, this becomes a volumetric scatter. So you can be just purely refractive, which you would need a volume box underneath, or volume scatter, which you don't need anything, or you can mix between the two. So you could do, if you had a volume box but you wanted the refraction in there, you can actually, it's not one or the other, you can actually do both. But for this, we are just doing volume scattering. Pick a color that kind of feels like it makes sense. Scattering density, you don't need to go too high. I think if you go above 1 or 5 or 10, it looks a bit weird. It's a bit too, almost like smoke. Too low, and it's a bit too transparent. So yeah, this value seems good. And that's it. And there is a little bit of incandescence emission. So I think I've just got it left at 1. And the cusp is just being used to drive that. Cool. So that's all done. Generic environment light. And let's just render this. So I'm going to render it double what the camera is. So I think it's 2.5K, I think, this resolution. So we should just get this rendering. Cool. I'll just double check. Yep, so that's 2.5K. So this is what I would say is a pretty good resolution ocean. Probably go even higher if we wanted to. And that's just the cusp pumped into the emission. So it's actually doing an emissive component in here, which ends up working pretty good. Cool. So, we could send that to the 3delight cloud and there will be no dependencies on anything. It's just going to upload the texture and the scene file, and away we go, and we're done. So that's it for the creation of it and the baking of it and the Houdini side of it. So we'll just quickly go into Maya. And before we do, I'll just say that, what we want to pass to Maya is I'm just baking out an alembic of the grid. So we know we're in the, the same spot. So save that and guide to disk. And I'm also baking out the camera via the good old fashioned file export, alembic, choose the camera, and away you go kind of thing. So come over to Maya and we should have the grid. So I've got this shot camera, I've got this grid here. Actually, I think I might have moved the camera. So let's rebake the camera to be sure. So let's go export, alembic. We want to pick, just the camera, pick the path to this, and where am I? Ocean, export to Maya, shot cam, and maybe we'll just increment the shot camera so that we don't destroy it. Cool. And you actually have to always remember to put the file extension here, because even though you're exporting alembic and you're telling it it's an alembic and it's an alembic exporter, it's too dumb to know to put the file extension there for you, so you need to put the file extension there. Cool. So that camera's baked out, and we can just go to the cache, import alembic, and we should be able to find the second shot camera. Cool. And let's look through second shot camera and environment light. Who cares? I think the environment light you can change the display of the environment light in the view to see how big it is or whatever, but we don't care about that. So the ocean bake side of things, I'm pretty sure that we shouldn't need to reload this, but I might do it anyway. Shouldn't need to. Were they different? Pretty sure that they're the same size. Oh, this light is really annoying. And I do not use Maya ever. Display maybe? God damn it. Visibility? Oh, there we go. I need to turn that back on probably, or it won't render. Okay, so that's the original, which we want to get rid of because obviously I did scale it up. Yep, that's right. I did scale this up. Put that back on. Cool. So back through, and we're in cam 2. Who cares what the Maya viewport is doing? We don't really care. So we want to select that ocean, and we just want to remember to assign existing material, which is the 3delight ocean. All good. Which, let's have a look at the hypershade. Okay, so as far as shading is concerned, same sort of thing. It's just a default principled material. The displacement input is using the ocean displacement. It needs to be pointed to the file that we exported. So exactly the same as Houdini. So we're pointing the displacement to here, and same thing with the cusp. We want the cusp to be pointing in the same file, and doing a similar thing with the remap. And the shading should be similar. The environment light might be a little bit different, but it should mostly be the same. So that's really all there is to bring it into Maya. So just quickly, and I realize I might have gone over that a bit quick, but yeah, it really is just a principled shader, and the shading group's displacement uses the ocean. Plug the texture in, same for the cusp. Do whatever you want, remap if you want, and you can always pipe it into incandescence, which is what we did in the other one. So we can select our 3delight and just go to the scene elements, make sure I update it to the new camera. Objects are good, it's just here. All right, this should be the same. Cool. So all we need to do here is, because the camera resolution coming out of Houdini was 1280 by 720, that's the only reason why that there is a difference between the two of them. So I'm not sure whether this plugin actually has options to do it, but it might. Who knows with Maya. 2560 by 1440. Whoa. Cool. Now let's try that again. Get rid of that guy. Got them to the. Oh no, I've definitely broken something there. Oh well, doesn't matter. It all renders the same anyway. Okay, so that is the same. Just the camera export out of Houdini. Although I think that's, yeah, who cares? Anyway, so that's how you render between the two of them. You know, it's identical, no difference. There we go. All done.